Today we're going to be learning about the different types of chemical reactions, and we're going to do that on the worksheet of Balancing Equations Practice 2. And we're going to be learning all these different types of chemical reactions from what we see written on this paper. We're going to start with the combination, or synthesis is another name for that. Combination means you're putting things together and you're making one product. So if you notice here, number 1 only has one product made from several things, so that's going to be combination. As we continue to look down the paper, we see number 9 has only one product, so that's also going to be combination or synthesis. As we continue to move down the paper, we look for reactions that have only one product, so that's going to be number 14. That's also going to be combination. And as we continue to look down, we see number 19 also has only one product, so that's going to be combination. Now we're going to look for reactions that are decomposition. That is the opposite. So decomposition means you are taking things apart, so that means you're going to have only one reactant. So as you look at number 2, you see that this has one reactant, so this is going to be a decomposition. As we move down the paper, we see number 7. Number 7 also has just one reactant, so that's going to be decomposition as well. We'll scroll down the paper a little bit, look for one reactant. We see that in number 12. Number 12 only has one reactant, so that's going to be decomposition. And number 16 also is decomposition. So those are all the decomposition reactions. Now we're going to look for single replacement. Single replacement is going to be where one element kicks out another, and it can either be anionic, which is a negative kicking out a negative, or cationic with a positive kicking out a positive. So you're going to look for an element by itself and a plus minus. So here we go. Look at number 8. We have an element by itself and a plus 1 minus 1. You could think of water as H plus and OH minus. Now Na wants to be a plus 1. So if it wants to be plus, it's going to kick out the other plus, which is the hydrogen, and go with the hydroxide. So now the hydrogen is all by itself, as you could see on the right-hand side, and the sodium is now with the hydroxide. So this is called single replacement cationic because it's a plus kicking out a plus. Now let's go to number 10. We see an element by itself and a plus minus compound. So chlorine wants to be minus to be chloride. That means it wants to go with the plus and leaves behind the bromine by itself. So now the bromine is by itself and the K went with the Cl. And this is now going to be called single replacement, but it is anionic because a minus kicked out a minus. If you look right below it at number 11, same thing. Element by itself, a plus and a minus. The fluorine wants to be minus, so it goes with the plus, leaving the chlorine behind. And that's going to be single replacement anionic. We'll move down the paper, see if there are any other single replacements. And we see number 18. Number 18 is an element by itself, which is magnesium, with a plus minus compound, FeCl3. The Mg wants to be plus 2, so it kicks out the other plus. It goes with the minus, and the Fe is left by itself. So this is single replacement. Since a plus kicked out a plus, it's cationic. Now we move on to double replacement. Double replacement means you have a plus and a minus and a plus and a minus, and they switch spots. So look at number 3. Number 3 has a plus and a minus and a plus 2 and a minus 1. And look at what happens from left to right. The Ag used to be with nitrate, and now it goes with the chloride. And the calcium used to be with the chloride, now it goes with the nitrate. So they switch spots. So you can see on the right side that Ag is plus 1, chloride is minus 1, calcium is plus 2, and nitrate is minus 1. So that's going to be a double replacement. Look at number 5. You have a plus 2 and a minus 1. a +1 and a -2. They switch spots on the right side. Because the calcium is +2, it matches up with the sulfate, which is -2. And the potassium and the bromide also match up, and so that's going to be a double replacement. Scroll down the paper a little bit to the last couple. We're again looking for +- with a +-, and we are not going to have any more of those on this paper. So now we go to combustion. Combustion means burning. Complete combustion versus incomplete combustion. So here's how to tell. Complete combustion is going to be something plus O2 yields CO2 plus H2O. Whereas incomplete combustion is something plus O2 yields carbon monoxide plus H2O. So everything is going to be with oxygen on the left. You're always going to have O2 on the left. And then you're always going to have water on the right. And then you're either going to have CO2 or CO in the products for complete versus incomplete combustion. So let's look at the first half of our paper here. And we see in number 4 that we have oxygen on the left and CO2 on the right with the water, so that's complete combustion. Look at number 6. We have CO and water, so that's going to be incomplete combustion versus the CO2 in number 4. All right, we'll continue to look down the paper for the ones we have not labeled yet. And we're going to look at number 15, and we're going to see that one is making CO incomplete combustion, so IC is our code for that. And then look at number 17, it made CO2, so that's going to be complete combustion. All right, now we're going to look at the ones that are left, and look at that. Number 13, we missed. 13 is a +-, so that's going to be a +2 - 1, +1 - 1. So that's going to be a double replacement. And let's scroll up a little bit. We filled in everything. The only thing we have not finished is number 20, and that was a little bit of a trick question. You could see that it is the backwards of combustion, but this is actually photosynthesis, which you learned in biology, where plants will take carbon dioxide and water to make glucose and oxygen. So this will not be on a quiz or test, but it was just a good stretch. Now you can label all of your types of chemical reactions in every worksheet that's assigned. Today we're going to be learning how to write word equations into chemical equations. This is going to be based on the Chapter 11 Chem 1 worksheet number 6, word equations. So these word equations right here are going to be coming from these words. We'll start with number 2. We're going to turn these words into formulas now that you know how to write formulas. So we're going to start with number 2, barium chloride. You'd look on the periodic table and you know that barium is, do that with a different color here, barium is a +2, so you'd have to notice that from being in group 2. And you know that chloride is -1. So since this is a +2 and a -1, this has to be BaCl2. Now you're going to put that together with nitric acid. Nitric, ick came from 8. So I'd hide if I ate something icky. This came from nitrate. Nitrate is NO3, -1. So since H is +1, you're just going to have an HNO3. Then you're going to make the products on the right side of the arrow. Barium, as you know, is a +2 charge. So we'll write barium +2. Nitrate on your polyatomic paper is NO3, -1. So we got NO3, -1. And so you're going to need 2 bariums to match up with the, 2 nitrates to match up with the barium. So you're going to put parentheses and then a 2. And lastly, you have hydrochloric acid. So hydro came from ide, which is chloride, Cl-. So when you put H pluses with that, they match up, and it's just HCl. So now you've written what's called the skeleton equation. Now what you need to do is you need to balance this equation. So we'll switch to red, and now realize that you must only put numbers in the front of the equation to balance it. Usually it's best to start with the most complicated looking thing. So I would maybe consider the barium nitrate right here, which looks complicated. So let's start with the barium. We have one barium on the right and one barium on the left. So that's going to have us put a 1 here and a 1 here. And now your choices are either go to chloride or nitrate. I'll just go to nitrate. So when you go to nitrate, you'll see that there are 2 nitrates on the right, but only 1 nitrate on the left. So now you're going to put a 2 in front of here. By putting a 2 here, you've now changed the hydrogen. There are 2 hydrogens on the left, and there's only 1 hydrogen on the right. So you're going to need to put a 2 in front of this, which also made 2 chlorides. So 2 chlorides on the right, and you already have 1 times 2 chlorides on the left. So now you're balanced. So this worksheet right here, this worksheet is putting together lots of skills that you've learned. First, you're going to take the words and turn them into formulas. Take the words, turn them into formulas with the pluses and the minuses matching up. Then once you're done, you're going to put a line in front of each one, and you're going to balance the equation like we learned earlier as well. Lastly, you're going to identify the reaction by type. And so that'll be on a separate video, but here is just a quick reminder of how to do that. You have all these different kinds of reactions: combination, which is the same as synthesis; decomposition, single replacement; double replacement; complete combustion; and incomplete combustion. This is a double replacement because you have a plus and a minus and a plus and a minus, and they both switch spots. So the Ba goes with the NO3 and the H goes with the Cl, and so you can see on the product side they're rearranged, and this would be called a double replacement reaction.